Good morning and good afternoon, everyone. I am Sarah Aamir, a partner solutions architect at AWS, specializing in generative AI technologies, specifically focusing with financial services industry vertical. Today, let's walk through how EDA, fueled by AWS services and generative AI, can enhance everything from operational efficiency to customer experiences. As you all can see, the topic today for us is leveraging AWS services and generative AI in event-driven architecture, as EDA when we call. So basically, we're not discussing just the technology here. We're talking about a shift in how we solve those complex business challenges. Today, we are diving into an exciting intersection of technology, event-driven architecture, and generative AI. As we explore this, I want you all to think about these tools, how they can transform our approach towards automation, responsiveness, and scalability, and all that happening in real-time applications. With that, let's have a look on these three major criteria from learning objective perspectives. Our session today is anchored around these three main learning goals. First, we'll start with the basics of event-driven architecture and why it's valuable for today's systems. Then we'll dive into how generative AI adds an intelligent layer to these architectures, which are pre-existing, and enabling deeper insights and faster reactions across different industries. Lastly, I will introduce you all to the AWS services specifically designed to support this powerful combination. So by the end of this presentation, I hope you all will be able to realize the potential these tools hold for creating adaptable and data-driven solutions. This presentation, I would like to mention a little bit of a persona perspective for the targeted audiences is certain aimed at software architects and developers interested in event-driven systems, data scientists and AI ML professionals looking to integrate their models into larger systems, and also business leaders and decision makers seeking to understand the potential of EDA and generative AI in their operations from business use case perspective. And of course, last but not the least, cloud architects and DevOps engineers working with microservices. With that, so let's think about what is event-driven architecture. I'm pretty sure a lot of the people watching must be aware of it, but just for the sake of those who are new, I would like to mention a little basics about that. Simply put, EDA enables systems to respond to real-time events by triggering automated workflows. Imagine a system that isn't just scalable, but also agile, and one that reacts instantly to new information. This is essential in our data-saturated world where agility, real-time responsiveness, and scalability defines our success criteria. What I'm trying to say is EDA isn't just nice to have anymore. It's a fundamental approach for businesses aiming to handle high data loads efficiently. Think of these microservices executing serverless functions based on these events, with centralized event broker overseeing this entire orchestration. Some of these differentiator factors or benefits, what you see on the screen, starting with agility, where EDA enables the businesses to adapt to changing needs quickly, and real-time responsiveness, which brings the systems where they can instantly react to events, enhancing their user experience. Scalability is the aspect where EDA accommodates high data loads, maintaining performances with ease. Microservices, obviously, EDA handles the events by executing serverless functions. And brokers, as we just mentioned, centralized event management and dynamic routing by overseeing the entire orchestration is where it holds the perspective. Now, on the screen, what you see, let's focus on EDA components here. EDA relies on three main components, as what you see: event producers, event brokers, and event consumers. Imagine a well-coordinated system where producers detect the changes in state, like a customer action or system alert, and pass this information through a middleware where the communication hub takes place. And this enables the reactionary components or consumers to spring into the action. So a key advantage here is flexibility. We can connect on-premises systems with cloud environments or even integrate multiple cloud providers seamlessly. This kind of a setup is useful for businesses, I would say, with diverse tech stacks or maybe hybrid cloud strategies, giving them a unified, efficient way to manage data flows across regions or environments. With that, let's talk about something interesting. Now, you all might wonder, where does this generative AI fit into this picture, right? Generative AI, the term, which is explained in a manner that powered by the foundation models, isn't just for creating content. It's designed to learn complex patterns from vast data sets. You can train it to learn human language, programming languages, art, chemistry, biology, or any complex matter. It uses its training data to solve new problems. And in other words, let's say, picture a system capable of generating tailored experiences, detecting patterns, and predicting the needs, all in real time. And all of that is powered by large models referred to as foundation models. That's how we use this term, particularly for generative AI. So rather than developing the artificial intelligence from scratch, these foundation models, which are the large deep learning neural networks, are used as a starting point to develop any machine learning model solution. Let's talk more about that. I know I just mentioned foundation model, and there must be questions. What is that? So a foundation model, I would describe as a paradigm for building AI systems in which a model is trained on a large amount of unlabeled data, can be adapted to many applications simultaneously. What makes a foundation model special is that they can perform so many more tasks because they contain such a large number of parameters that can make them capable of learning complex concepts pretty quickly. And through their pre-training exposure into the internet scale data in all its various forms and patterns, these foundation models learn to apply their knowledge within a wide range of contexts. So while the capabilities and resulting possibilities of a pre-trained foundation models are amazing, customers do get really excited because these generally capable models can also be customized to perform their specific or domain-specific functions, and that are differentiating to their own businesses, using only a small fraction of data and compute required to train a model from scratch, and then utilize it in an iterative manner. Okay, now let's talk about a little integrating generative AI, how we can do this for new experiences and bring what kind of a business value and on a very high level. As I mentioned before, generative AI isn't just about technical advancements, it's about creating value. With generative AI, we can design more engaging customer experiences, improve employee interactions in ways previously unimaginable. Think of it as a way to build entirely new dynamic customer journeys. Imagine a customer receiving a product recommendation that is perfectly aligns with their interests based on a live behavioral data. Or just an employee receiving real-time insights to make decisions faster and more confidently and efficiently. Just by embedding this generative AI into EDA, we don't just process the data, we create the experience and unlock the value at every touch point, which we will be able to see some few examples on my upcoming slides. All right. So here is a slide I would like to give a perspective about how our partner Solus. Let's have a look at how Solus, when there pops up EDA as a great partner, and having this event-driven architecture pattern is integrated with AWS. I'm going to divide this into a pre-amp and post-amp, which you see on the screen pattern, where Solus handles the raw, high-volume event ingestions with topic-based routing delivery to AWS's Event Bridge and any third-party endpoint. AWS Event Bridge then owns the final content-based delivery, which you see on the screen, to the backend AWS services. Solus here is acting as the preamp, taking all the raw events from anywhere in the enterprise. And these could be from on-premises locations, IoT devices, connected vehicles, or a private cloud or a different hyperscaler even. And these could exist anywhere in the world, as well as low latency, high throughput, guaranteed delivery in order, all a part of the QoS, and yet all secure. So these Solus ED events can be delivered to AWS Event Bridge instances across different regions. And once there, Event Bridge from AWS can do the last mile delivery, basically, using content-based routing and supporting all AWS native services. With that, let's have a look on what the combined speed looks like. At the tools of AWS offers and Solace's EDA, bringing generative AI as holding the glue, AWS has a powerful suite of services tailored to event-driven architecture and generative AI. Each service plays a unique role in making Solace's PubSub EDA not just responsive, but highly intelligent. For example, I'm going to talk about a few services, how the EDA transfer all this data to Amazon Kinesis, which streams the data, enabling real-time analytics and decision-making. And then AWS Lambda then comes into the play, handling serverless event-driven actions. And when we add Amazon SageMaker, it makes it possible to analyze that data which has been transferred by EDA to make predictive insights a natural part of the workflow. AWS gives the tools to deploy EDA systems with a high degree of automation, flexibility, and intelligence. Basically, in a summarized manner, imagine each of these services is a part of a well-oiled machine, capturing data, managing responses, generating insights. It's the orchestration that lets us deliver the smarter application faster, all while focusing on innovation. Well, I know. Enough talk about EDA and generative AI, I believe, right? Now let's dive into the actual use case scenario that you see on the screen. The first use case of a real-time decision-making. A critical area for many industries, I would say, especially finance, as an example I used here. Imagine a banking system capturing thousands of transactions per second, with Solace PubSub EDA as an example used here, transferring events to Amazon Kinesis, where it can stream the data continuously. And then Lambda comes into the picture, which can trigger a fraud detection model into SageMaker to assess it, all happening in real time. We are analyzing each transaction for anomalies, protecting users, and reducing fraud risks instantly. So this isn't just a technical feat, right? It's a real advantage in a competitive market where speed and accuracy makes all the difference. By leveraging EDA with generative AI, we are enabling these financial institutions to act faster, smarter, and more securely. Having a glimpse on this flowchart, what you see on the screen, I would say, let's say from the perspective of how it works. Events from Solace EDA, as an example here, are as transaction data flows into Amazon Kinesis, which streams the data in the real time. Amazon Lambda comes into the picture, triggers the process to analyze transactions instantly, sending relevant data to SageMaker. Amazon SageMaker models then assess these transactions. They can train the data or the foundation models, patterns, and then identifying those potential fraud indicators, alerting the systems for further action. And then those alerts can be sent back to the system via EDA again. Here's another use case as enhanced customer experience. Let's discuss how, again, we have Solace's EDA as an example with generative AI, using customer experiences, particularly in the areas like e-commerce industry, as an example I've used here. Picture a scenario where customer is browsing, and I think this one is something we all can easily relate to. Customer is browsing through products on an online platform. Solace EDA can capture each interaction, clicks, searches, views, and feeding all this important data into Amazon Personalized. So how it basically works from the flowchart perspective is customer interactions are captured by EDA here, triggering responses through Amazon Connect. Then the data flows into Amazon Personalized, which you see on the screen, using generative AI models that can generate highly personalized product recommendations all in real time, and tailoring those suggestions to what the customer most likely want to hear or see. So in other words, this doesn't just boost the engagement, it builds a more intuitive and satisfying customer journey and experience. Imagine your customer feeling like every recommendation is crafted just for them. And this is the kind of experience EDA and generative AI together can deliver. Another compelling example here is I have chosen to impact on a manufacturing industry where operational efficiency is paramount. Imagine a factory where IoT sensors feed data into AWS IoT Core, and Amazon CloudWatch continuously monitoring that equipment's health. Solis's EDA, as an example we are using, is combined with generative AI, can analyze these data streams, allowing our systems to predict and prevent this equipment failures simultaneously within real time. Think about the impact: fewer breakdowns, lower maintenance cost, and minimal downtime. It is not just about avoiding the issues, but it's about achieving optimal performance every day. And this is what the power of real-time insights coupled with intelligent automation brings you upward. How it works, let's talk about briefly, is these sensors and IoT devices are continuously monitored with the equipment status. Solis's EDA is capturing this scenario here with all those anomalies or performance deviations, sending this data to AWS IoT Core, where Amazon CloudWatch monitors these events on the screen. And then when we maintain, where the maintenance is needed, generative AI models takes or step into this picture by SageMaker and suggesting the optimal maintenance schedules or any actions which we need to prevent the potential breakdowns. Let me remind you that Solis's EDA can provide the data all over the world to AI for enhancing this efficiency, and EDA can be used again back and forth to shut down the problematic sites also. For example, when AI orders to shut down after analyzing some kind of anomalies, EDA sends that trigger to the relevant subsidiaries. Now, let's look at a personalized marketing scenario from retail industry example perspective, where we have shown Solis's PubSub EDA again with AWS Generative AI together to revolutionize how we communicate with customers. EDA tracks user actions on digital platforms, such as purchases or clicks, and instantly triggers these personalized emails or offers through Amazon SES or Amazon Step Functions. SES stands for Simple Email Service. For example, a customer's recent browsing behavior can generate tailored marketing content that lands in their inbox where they are most engaged. And this approach helps the retailers send highly relevant, customized messages to the customers, strengthening their brand's loyalty and increasing conversion rates. And this kind of proactive data-driven outreach is what today's customers expect to respond to. So basically how this works is, Solis's EDA here is tracking user interactions, such as clicks and page view, as I mentioned before. These events trigger the workflows via Amazon Step Functions. Customers' data is processed by Amazon SES, Simple Email Service, which personalize email campaigns, or this can also be used as promotion aspects of it, to sending the right promo code or promotional news to the relevant customers. And then generative AI refines the content based on user preferences, ensuring timely and relevant engagement with each customer. Finally, let's consider the use of EDA and generative AI in generating this data-driven insights and analytics, especially useful in healthcare, as an example I have used here for the industry, and any other analytics-heavy industries. Here, EDA captures the processes, massive event datasets, which are then streamed into Amazon Redshift, as you see, and visualized with Amazon QuickSight, which is a BI, business intelligence service. And SageMaker can analyze these patterns, delivering predictive insights that can improve decision-making. For example, or for instance, let's say in healthcare, a patient's data can be analyzed to predict the health risks or treatments needed, allowing the preemptive interventions to lean in. With EDA and generative AI, organizations can go beyond simply tracking the data, not only, but they can derive actionable insights that drive better outcomes and efficiencies. How it works is like large data sets from Solis EDA is showing from various sources are streamed through Kinesis into Amazon Redshift, where they are stored and processed as a data warehouse. Through Amazon QuickSight it's been visualized into a data trend that, for example, which patient is on a higher risk to be treated for a certain treatment or on the list of more high alert. While generative AI is doing the back work within SageMaker to analyze these patterns to produce actionable insights, such as patients' risk scores in healthcare, enabling timely interventions for that matter. With that, I think, yeah, that was good amount or a dose of use cases, but definitely these are not the only. We have several more. It's just the time we have to be more cognizant about. So let's talk about the best practices of EDA with generative AI. As we consider implementing EDA with generative AI, let's recap the best practices as a solid foundation. First one, the way you see on the screen, to select runtime. Apologies. The right choices here will ensure that events are captured and routed seamlessly by selecting the right runtime. Some of the examples would be like evaluate quality of service and latency requirements, consider data sources and destinations correctly, and analyze the expected data volumes in time, before time you go ahead for implementing something. And if you comes to the generative AI aspect of it, you have to identify the appropriate large language models to enhance your EDA performance. Secondly, selecting the right design time, where governance and compliance and event sources takes place. Basically, in an environment handling vast amounts of data, governance is certainly essential. Ensure that the data flows and permissions align with your organization's security and compliance standards by selecting the right design time along with the event sources. Some of the examples I would say the options include is Amazon SNS, the simple notification service, Amazon Event Bridge, and assess this suitability based on your architecture. Third main aspect is pilot testing. Start small to see how the system performs under real-world conditions. I think a pilot approach gives you invaluable insights and lets you tweak as you need as you go, since we all are going to be testing aspect of it. So low-hanging use cases, I would suggest select a straightforward approach use case to transition from design to deployment, showcasing the value of a minimal viable product or MVP, let's say. So by following these best practices, we set up our system not just for success, but for a long-term growth and adaptability. And as we wrap up, I want to look ahead. The future of EDA, combined with generative AI, points towards highly adaptive, intelligent systems that reacts to events and learn from them in real time. We all are on the verge of having systems that don't just support business processes, but actually drive innovation in those processes. Imagine systems that continuously evolve using data to adapt and refine their own workflows. And this is the promise of AI-driven EDA, a future where responsiveness and intelligence are no longer add-ons, but certainly built-in capabilities rather. So with that, thank you so much for joining me in exploring this journey. I would love to hear any questions, thought, or experiences you may have with EDA and AI innovation. Here are my contact details and feel free to reach out and always keep exploring. Thank you.